about graphing. So a graph is a visual way to organize your data from a data table. And there are typically 4 types of graphs, at least that we will be using in science. So there are bar graphs, which is probably one you're most familiar with, which looks like this. So the examples are always to the right. So here's an example of your bar graph. Obviously, there are bars that tell us the amounts that it has. So a bar graph compares data that is grouped by name or category. Our second type of graph is a scatter plot graph. So this compares the relationship between 2 variables. So usually the dependent and the independent variable, but it does compare the relationship between any 2 variables. It also uses a line of best fit. To determine the kind of relationship that it has, and the line does not connect all of the points. We do use these every so often. I would say that we probably use line graphs more than we use scatter plots, but we do see them sometimes. So then our next kind is a line graph. It shows the trends in data over a period of time. So that right there is very important. It always has to do with time. It could be years, it could be minutes, it could be months, it could be centuries, whatever it is, it's over a period of time. And when we do have a line graph, the line does in fact connect the dots. You can see here, it connects all of these dots instead of just making a trend line all the way through showing that it goes up. It does go through every point and connect each and every dot. And the last type of graph that we don't really have you guys ever make because usually we don't have access to computers. Maybe now that you guys have access to internet and computers, we might do a few more, but it's not really typically a graph that we use. In college, you use a lot more of these pie charts, and it shows the amount of each category out of a whole 100%. So if you were to do these kinds of graphs, you would have to add up all of your numbers out of 100 and get a percentage. So it's a little bit more technical. So there are some things that we want in a good graph. So when you make graphs, or if we're making them on the computer or on paper, either way, there are some things that you need to know on how to make a very good graph. So for a good graph, you have your title, and your title should be the dependent variable versus the independent variable. Now this is backwards. When we talked about hypotheses and writing questions, it was usually the independent variable first. Graphs are the opposite. They are different. They write the dependent variable versus the independent variable. Our independent variable always goes on the x-axis. We went over that in data tables. So our dependent variable goes on the y. We label the independent variable and dependent variable with units if we were measuring anything. So centimeters, milliliters, liters, always use your units. Seconds. Our scale basically is saying that we should use up most of the graphing area. So if I give you a whole page to do a graph on, don't do it in a little tiny corner. It should be spread out. Use the area that's given to you. Make sure you plot your data correctly. So don't be skipping lines, count in sequential order, or I mean, you can skip lines, but don't go all over the place, like go like doo, 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 when it's supposed to be just a normal upward stroke of a line. So just make sure that all your data is being plotted correctly. You're counting by 2s or 5s or what have you. And then if you need to draw the line of best fit, make sure you have one. Next, there are graphing relationships. So when you're looking at a graph, you can usually tell the kind of relationship it has. There is a direct relationship when one variable increases or goes up, the other variable also increases or goes up. This would be an example of a direct relationship. As the x value goes higher, the y value goes higher. Then an indirect relationship is when one variable increases the other variable decreases. So for example, the x is getting higher, but the y is going down, it's getting lower or decreasing.